Roosevelt, Maryland, and I'm joined by Dr. Lucy McFadden, NASA planetary scientist. Lucy, how are you doing this evening?
Fine, thanks, Sarah. It's great to be here. It's exciting.
Tell me, how excited are you for this mission?
Well, I know how everyone's heart is beating and racing down at Cape Canaveral, and I'm just so excited for them. And we're coming into the countdown, and I just can't wait to watch this bird take off.
And as you can see behind me, our visitor center is filling up very fast. Can you tell me a little bit about the excitement in the room?
Oh yeah, well, it's great that everyone's coming out at the dinner hour of the first week of school, and they're taking a break and coming out to watch this with us and to be part of the OSIRIS-REx mission. I'm really excited to see so many people here.
It's very, very exciting indeed. Now, Goddard has played a special role in this mission from the very beginning. Can you tell me a little bit about what Goddard has done?
Yeah, well, Goddard has overall management responsibility for the OSIRIS-REx mission, and one of the instruments was built here, and we have also done safety and mission assurance. So many of our Goddard colleagues are participating, and we have scientists here too who will be studying the sample when it gets back from Bennu.
Can you tell me a little bit more about that? How our scientists will be studying that sample when it comes back?
In 2023, after the sample lands back on Earth, we have our scientists in the astrobiology lab who will be studying and looking for the amino acids and the organic components that make up the building blocks of life. And so they will be finding the fragments from the components that seeded life here on Earth. And we're really looking forward to that. They've got great lab facilities. They've been preparing for this, developing their contamination procedures, and so they're really excited and ready for this.
Definitely, definitely. Now, what specific things are we going to be looking for in those samples? I know you mentioned the amino acids and...
Right. Well, the building blocks of life are the carbon compounds. And carbons can form very simple elements, but then they keep growing in different chains and different structures to grow into amino acids and then the proteins and then the processes that bring us the building blocks of life.
Definitely, definitely. Now, and is that one of the reasons that we chose Bennu as our asteroid of choice?
Yeah, well, Bennu is close to the Earth. It's accessible. It is of the right size so that we can go and touch and go and pick up the sample and bring it back without contaminating it. And it has the right composition because it's carbon rich, it's dark, and contains a lot of the compounds that we're looking for and that will allow us to piece together the process from organic materials into something that creates living life as we know it today.
Definitely. Well, OSIRIS-REx will be launching very soon, and we are looking forward to seeing it lift off. So thank you, Lucy.
No, thank you. Let's go watch it and not miss the launch.
Okay, thank you both. Lots of excitement around the country as we are standing by for the liftoff of OSIRIS-REx in a little bit under 23 minutes from now. This is Atlas Launch Control.
T-minus 6 minutes.
Fuel fill sequence is complete.
Roger.
T-minus 5 hours, 20 minutes.
SYS start radar stat acquisition.
This is
Roger.
Atlas Launch Control. We are at T-minus 5 minutes and counting. Counting down toward our last planned built-in hold at T-minus 4 minutes. It's a 15-minute hold, during which time all the systems will be checked, a number of polls will be conducted, and given the current condition, we expect that we will come out of the hold and count down toward launch at 7:05 p.m. Eastern Time. Here at Launch Complex 39, crowds are gathering in anticipation of liftoff of the Atlas V rocket and OSIRIS-REx. And we're standing by to go into our hold.
Program 15-minute hold.
And we're in our hold at T-minus 4 minutes. It's a planned 15-minute hold. This is Atlas Launch Control. Launch minus 17 minutes and counting. In about 4 minutes, the terminal count readiness poll will be conducted. One of several polls will be held during this hold in order to assure that everyone is ready for launch. You're looking at the Atlas rocket at Space Launch Complex 41. The rocket is 189 feet tall, about 19 stories, and weighs more than 700,000 pounds fully fueled. And with the combination of the RD-180 engine and the strap-on solid rocket booster, the Atlas will lift off, courtesy of 1.2 million pounds of thrust at 7:05 p.m. Eastern Time. This is Atlas Launch Control at T-minus 4 minutes and holding. And if you're just joining us, we're just under 15 minutes away from launch as managers assess the health of the Atlas V rocket and spacecraft during this planned 15-minute hold. No technical issues of note are being worked. Weather is 90% go, and crystal clear skies seem to ensure that we will not have an issue with the weather today. During this hold, NASA Mission Manager Rex Engelhardt, OSIRIS-REx Spacecraft Mission Director Mike Donnelly, NASA Launch Manager Tim Dunn, United Launch Alliance Launch Director Bill Cullen, and United Launch Alliance Launch Conductor Scott Barney will be pulling their teams of engineers across the country, culminating in the decision to release the hold at 7:01 p.m. for an on-time launch at 7:05 p.m. And if any issue should crop up, the hold could be extended. The launch window this evening lasts an hour and 55 minutes, so we could launch as late as 9 p.m. But again, everything is proceeding normally at this time, and we expect an on-time liftoff at 7:05 p.m. Eastern. This is NASA's first mission to take a sample from an asteroid and return it to Earth. The OSIRIS-REx mission will help scientists investigate how planets formed and how life began, as well as improve our understanding of asteroids that could maybe one day impact Earth. OSIRIS-REx is traveling to the near-Earth asteroid Bennu, where it will bring a sample back to Earth for study as part of NASA's quest to study our solar system and beyond. And we're standing by for the first of our launch poles. NASA Launch Manager Tim Dunn conducting a poll. His team is go for launch. We'll continue to listen to the various audio circuits where managers will be conducting their polls, culminating in a final go-no-go poll as we approach the end of our hold at about 5 minutes away from launch. This is Atlas Launch Control. This is Atlas Launch Control, T-minus 10 minutes, 27 seconds, and counting. In a little bit more than 10 minutes, OSIRIS-REx begins a 7-year journey, reaching its asteroid target Bennu in 2018. And after a survey of the asteroid to characterize it and locate the most promising site, OSIRIS-REx will collect a sample with its robotic arm and return it to Earth via a detachable capsule that will parachute to Earth in 2023.
Any time after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold.
L minus 9 minutes, 30 seconds.
NSC LC-Net 1,
Tennessee.
spacecraft to internal power.
Roger.
NASA Spacecraft Coordinator Brett Perkins asked to transfer OSIRIS-REx to internal power.
Enable position.
SRB ignition enabled.
Verify FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Red line monitor and event table are in the correct configuration for terminal count. Roger. Flight control, perform launch on time verification.
Roger.
T-minus 8 minutes, 35 seconds and counting. Everything remains go.
Launch on time verified.
Roger. RC verifies solar radiation acceptable for launch.
Verified.
LC switch to ready position. All steps are complete prior to the status check.
And NASA Spacecraft Coordinator Brett Perkins confirms that the OSIRIS-REx spacecraft is on internal power, key milestone leading toward launch today. We're at T-minus 4 minutes and launch minus 7 minutes, 16 seconds and counting. Number of polls being conducted so far, no issues. Everyone continues to be go.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer. Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. Timer T0 is planned for 23:05 Zulu. Set count to start at 23:01 Zulu.
Roger. T0 is set for 23:05 Zulu. Count will start at 23:01 Zulu.
Launch polling is complete and we have a go for launch in 5 minutes, 37 seconds. We're about a minute and 30 seconds away from coming out of our T-minus 4 minute hold.
CNET 1.
Tennessee.
Verify spacecraft is on internal power.
OSIRIS-REx is on internal power.
All steps are complete prior to terminal count.
And once again, as you heard, OSIRIS-REx is on internal power. Launch minus 5 minutes. 1 minute away from coming out of our hold. From now until launch, you'll be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team securing Atlas liquid oxygen topping, followed by the call to transfer the Atlas
On my
and Centaur
mark,
stages.
T-minus 4 minutes and counting. 2, 1, mark.
And we're at T-minus 4 minutes and counting. Atlas and Centaur stages will be transferred from ground facility power to internal battery. At T-minus 1 minute 55 seconds, the team will command the ground launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. T-minus 3 minutes and counting. A brief look at the Mission Director Center and the Atlas Spacecraft Operations Center.
Yes, internal.
And the Launch Control Center. Flight termination system is on internal. Everything is going by the timeline. Standing by to transfer the Atlas power to internal and the Centaur power to internal in about 25 seconds. Once again, crowds gathered expectantly awaiting today's launch, a little more than 2 minutes away. T-minus 2 minutes and counting.
1 minute 59,
Vehicle internal.
155,
Launch sequence for start.
150,
Securing Centaur LH2.
Securing Centaur LO2.
140,
Launch enabled.
137,
Flight control system is to launch enable.
FTS armed.
In the final minute, the Atlas tanks will be verified at flight pressure, followed with verification of the Centaur tank pressures. 1 minute, 21 seconds and counting.
OCUs armed.
SCS count started.
115, 110,
At top clock.
T-minus 1 minute and counting.
Status.
Range green.
No issues with the range. Everything continues to be go. The final status check of Atlas, Centaur, and OSIRIS-REx readiness will be conducted 25 seconds away from launch. T-minus 40 seconds.
Step 3.
28, 25,
Status check.
Go Atlas.
Go Centaur.
Go OSIRIS-REx.
Everyone is go. Standing by for launch. After liftoff, you'll hear the voice of United Launch Alliance's Marty Malinowski providing launch vehicle ascent data. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Fire rates look good. Currently, pump speeds and injector pressures are within family. SRB chamber pressures have plateaued, begun to ramp off.
You heard the voice of Marty Malinowski. The Atlas has begun a pitch and yaw maneuver to steer to its planned path, 28.5 degrees inclination from the equator.
SRB chamber pressure is almost plateaued at this point. Already 180, injector pressures are good.
45 seconds into flight.
Whole program is complete. Boosters throttled down.
And the Atlas rocket carrying OSIRIS-REx has gone supersonic. Standing by to pass through max Q, maximum aerodynamic pressure.
Max Q, vehicle body rates continue to look good.
This is the point when the mechanical stress on the rocket reaches its peak
And
because of the
booster
rocket's
has
velocity and resistance created by the Earth's atmosphere.
Signatures look good. Current altitude is 14 miles. Downrange distance is 9 miles. Current velocity 2,488 miles per hour. Range track shows vehicle progressing down the middle of the range.
In about 30
180
seconds,
continues to look good.
the
Pump
single
speed.
solid rocket booster will be jettisoned at 2 minutes 19 seconds.
And booster has throttled back down. It's now 50% of its liftoff weight. Next major event will be SRB jettison, coming up momentarily. we
And
have
you see the
ignition.
solid rocket booster jettison.
Separation looks good. Vehicle has enabled closed loop Q alpha steering.
RD-180 engine continues powering the Atlas, Centaur, and OSIRIS-REx into space. Next major milestone will be booster engine cutoff, 4 minutes and 2 seconds into flight.
Has been fired. That system is now pressurizing to flight level. Signatures look good. Current altitude 40 miles. Downrange distance 75 miles. Current velocity 5,988 miles per hour. Range track looks good.
About 1 minute away from Atlas booster engine cutoff.
Already burn well. Pump speeds, injector pressures within band. Vehicle body rates look good. Vehicle is now 1/4 of its liftoff weight. Coming up on our 5G throttle segment momentarily. And we have begun throttling to maintain 5Gs. Signatures look good. Boost phase cooldown is underway. And begun to throttle to 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good.
Booster engine cutoff confirmed. Standing by after
And we have
spacecraft
separation.
separation for the Centaur single RL-10C engine to ignite.
We have ignition and full thrust on the RL-10. Coming up on payload frame jettison.
Everything continuing normally. The Centaur engine producing 22,900 pounds of thrust, and it will burn for just over 8 minutes.
Centaur body rates look very good. The steering has been enabled. And the payload fairing, which was covering OSIRIS-REx, was jettisoned
Everything continuing on the timeline.
Current altitude for Centaur is 101 miles. Downrange distance is 471 miles. Current velocity 12,589 miles per hour. We do have a report from the booster performance, and it is basically nominal. Centaur PU is currently on the OSIRIS stop. Chamber pressures look good. Box pump discharge, fuel venturi, and pump speeds all are good.
Six minutes into the flight of OSIRIS-REx.
RL-10 continues to perform well. Chamber pressures, box pump discharge, and fuel venturi all within expected range. Centaur PU has come off the lock church stop. Body rates controlling down the middle.
About 6 minutes left in the
Ready.
burn of the Centaur engine.
Battery voltages all are stable at this point. Tank pressures look good. And we have had the format change. Very minor loss of data during that. We're seeing our normal thermal conditioning firings on the RCS. Line temperatures have nearly warmed to bottle temperatures at this point.
Once again, you're hearing the voice of United Launch Alliance Marty Malinowski
Range track.
calling the ascent of the vehicle.
Still making good progress down the middle of the range. And Centaur has begun range steering at this point. Current altitude 139 miles, downrange distance 1,008 miles, current velocity 13,783 miles per hour. And the RL-10 continues to perform well. Chamber pressures, box pump discharge, and venturi all where we would expect for the ZMR. Centaur body rate still controlling down the middle.
About 4 minutes remaining in the burn of the Centaur engine. You can see the
Centaur
spacecraft traversing out over the Atlantic Ocean.
Downrange distance 1,275 miles. Current velocity
28.5 degree inclination from the equator.
Range track again continues to show good progress downrange. Centaur PU has worked off most of the oxidizer air at this point, controlling near nominal. Chamber pressures, box pump discharge, and fuel venturi, again, all as expected for the ZMR. Body rates are good. Centaur continues to perform well. Current altitude 145 miles. Downrange distance 1,597 miles. Current velocity 15,333 miles per hour.
Just a little over 10 minutes since launch, and everything continues to go well.
Approximately 2 minutes remain in this first burn. All Centaur systems look good. Centaur view again controlling near nominal. RL10 performance continues to look excellent. OSIRIS controlling down the middle. Approximately 1 minute remains in this first burn.
Standing by for the second stage Centaur engine cutoff.
138 miles, downrange distance 2,143 miles, current velocity 16,942 miles per hour.
MECO 1 coming up in about 10 seconds.
Vanish. And we have IAP vanish. Centaur is now orbital. And we have MECO. Engine shutdown looks good.
MECO is
We have
confirmed.
safety flight termination system. Centaur has gone to 4S settling.
Another Centaur burn will follow after about a 22.5-minute coast period. That burn is scheduled for 33 minutes, 48 seconds mission elapsed time, or about 7:38 p.m. Eastern Time. As the journey continues to
This coast phase is scheduled
put
for
OSIRIS-REx into its planned location in space.
followed by a second burn of 407 seconds, and a final coast to spacecraft separation of 15 minutes. Centaur tank pressures, storage bottles, batteries are all stable.
The Centaur engine will burn once again before finally releasing the OSIRIS-REx spacecraft into space about 55 minutes and 38 seconds after launch.
looking at the MECO 1 plus 3 second open, shows Centaur's right where we expected, and comparing the pre-flight to the actual position of the vehicle. Centaur RCS has begun ramp to a 25% forest duty cycle.
Once again, we're in a coast phase between burns of the Centaur engine. We're expecting that the next burn will begin in about 16 minutes. And right now, while we are awaiting the engine restart, we'd like to show you an interview that NASA Communications Representative Josh Finch conducted with NASA Chief Scientist Ellen Stofan.
Thank you. I'm here with Dr. Ellen Stofan, NASA's Chief Scientist. We're just outside of the Vehicle Assembly Building, and just a few miles away is OSIRIS-REx on the launch pad, ready to head to the asteroid Bennu to collect a sample and then return it back to Earth. Dr. Stofan, what can we learn about studying asteroids that could benefit us in learning about our solar system?
Asteroids are the primitive material left over from when the planets formed. So the Earth, us, this building, everything around us. Asteroids are the key to what were those materials that everything that is around us was made. Now everything on the Earth has been processed, all this material has been processed and processed. Asteroids are the pristine material, and we know they contain really interesting things like the water, that is the water that originated our oceans and all the water here on Earth. And they actually also contain organic molecules that help make us.
And so why did NASA pick Bennu as an asteroid to study, and what are the benefits of a sample return mission?
You know, Bennu is what we call a carbonaceous asteroid. Now, carbonaceous asteroids are the ones where we know they have a lot of water in them, and again, we think that water is the source of the water that's here on Earth, and we know they have organic molecules on them. In fact, some of the letters in our DNA that make up our DNA, those molecules have actually been found in carbonaceous meteorites. So Bennu could hold keys not just to the origin of water on Earth, but to the origin of life on Earth. So we're particularly interested in that type of asteroid. Now, when you send a spacecraft to either a planet or an asteroid, you take along instruments and you do the best job you can of characterizing the material. But you have to realize when we shrink a scientific instrument to fit down onto a spacecraft, it becomes a little less capable. If we can actually bring those rocks back here to Earth, we can analyze them with instruments that fill a room, basically. We get much more precise and better information. So scientists, especially geologists like me, we like to get those rocks back here on Earth where we can do really amazing science with them that we just can't do remotely.
And now NASA's planning to do an asteroid redirect mission and then eventually a journey to Mars. How does this mission help that goal?
You know, because small bodies are potentially really interesting in the future for resources, they're really interesting for water, and of course we're concerned about them from a planetary hazard point of view. Asteroids have hit this planet in the past, and they will hit us again at some point in the future. The asteroid redirect mission tests technologies like solar electric propulsion that we're going to use to get cargo out to astronauts who will someday be out at Mars. We're also going to be testing techniques that will help us understand how we might in the future potentially deflect a hazardous asteroid. So it's helping us protect this planet, and the asteroid redirect mission is going to help us to get us on our way to getting humans to Mars. And OSIRIS-REx is really the first step. It's teaching us how do we get to a small body, how do we maneuver around it, how do we get a sample back. It's the first step. The asteroid redirect mission is the next step.
Excellent. Well, thank you for being with us today. And back to you.
Thank you, Josh. Everything continues to go well. Once again, looking at animated graphics driven by real-time telemetry showing the position and status of the Centaur spacecraft with the OSIRIS-REx payload. The next burn of the Centaur engine scheduled for 33 minutes and 48 seconds after launch. So about 12 minutes from now. Once again, everything continues to go well. Heading toward an on-time deploy of the OSIRIS-REx spacecraft about 55 minutes, 38 seconds following launch. This is Atlas Launch Control. This is Atlas Launch Control, about 23 minutes following the launch of OSIRIS-REx. Everything continues to go well. The Atlas booster performed its job magnificently. The Centaur rocket burned and shut down on time. We're in the middle of a coast phase that will end in about 10 minutes, and at this time, we'd like to go back once again to the Goddard Space Flight Center in Greenbelt, Maryland, and talk with Sarah Schlieder. Sarah?
Well, congratulations to the entire OSIRIS-REx team on a successful launch. It was an amazing sight to see, and congratulations to you, Jim.
Go us!
Now tell me, now that we've launched, what are our scientists and engineers going to be doing over the next couple days?
They will be excitedly partying once we get on the way to the asteroid in about 15 to 20 minutes. We have our second firing off to Bennu. You know, they said, some people say this is better than Beyonce. This is Bennu. And so that's where we're going. So they'll be real excited and getting ready for the long haul as we travel out to the asteroid over the next 2 years.
Definitely, definitely. What was it like watching that launch?
Oh my God, it was great. The best cameras I've ever seen. We had rocket cams on rocket cams. And the kids wandering around dancing. I mean, this is the future of spaceflight. Going there vicariously with our Voyagers, and the excitement's palpable. I mean, I think our hearts are in our sleeves and whatever, but we're there.
Mm-hmm. And what does a mission like this mean to the next generation?
Well, this one especially, Sarah, is so important because it's going to bring something back. Not just lots of bits of data, but it's bringing back substances that we don't even know how to study right yet. But those young girls and boys of today in elementary school will invent the new tools to pick apart those samples, the way that we picked apart the relics of the past here on Earth in modern generations. So this will be a gift that keeps on giving. And OSIRIS-REx, is going to give us that. That's magical.
Definitely. So what is the next milestone for OSIRIS-REx?
So in a few minutes, I guess 10 or 15, I have to check my watch, we will restart the big Centaur engine. That's that big, powerful liquid oxygen hydrogen engine that will give us the push off to the asteroid. We'll do a trans-Bennu injection. And that will power us to the point where we'll catch up with Bennu, but on the way, we'll sling around Earth and get a gravity assist in about a year. So we arrive in late August of 2018. First pictures, mid-August, I guess, we'll see this black dot in space. That's where we'll be living for 2 years as we get ready to sample that wonderful place. So a lot happening in the next 2 years as we get ready for the science treasure trove.
Definitely, and I don't think the excitement is going to die down anytime soon.
Science never sleeps.
No.
Trust me, Dante will be up for the next 2 years.
Yeah. Well, it was very exciting to watch again, and again, we're looking forward to seeing all of the incredible images that we're going to get back from Bennu. I know the spacecraft is equipped with at least 3 cameras that are going to be documenting everything along the way, and it's just going to be a really incredible sight.
Well, we have 3 cameras plus a tag camera plus 3 laser altimeters, 2 spectrometers. I mean, this is bristling with instruments. It's like you just went to your medical doctor at a hospital, but we're doing it to an asteroid. So I don't think we've seen anything yet.
Right.
Just wait.
So Bennu and OSIRIS-REx are not going to be out of the limelight anytime soon. All right.
Be there, 2018.
Definitely, definitely. And what kind of documentation and imagery are we going to be getting along the way when we come back from the asteroid?
Well, once we get there, we'll start a series of lowering and lowering orbits to eventually, as we get ready to do those touch and taste high-five sampling maneuvers, the tag SAM, as the team calls it, we'll be only 10 feet above the asteroid. But we'll be doing a lot of mapping at a sort of a couple of miles above the asteroid. We'll have maps of the asteroid better than Google Earth of any place on this planet in different wavelengths. It's going to be staggering. And all that data will come right back. And the scientists here, across the team, Arizona, Goddard, Canada, will be just gushing with enthusiasm over it as they plan where to sample, because that's the next big thing. We have to figure out, what do we want to bring back? We've got this whole asteroid to figure out. So get ready. We haven't seen anything yet.
What are we looking for in a sample site?
Well, we're looking for enough debris where we can get small pebble-like chips, maybe the size of BBs or little ice chips. They won't be ice. We want that friable material to suck it into that sample capsule. We'd like to have some fine pulverized material, but the more big pieces we can get, the better they'll be to actually sample things that could contain the carbon. Those carbon molecules we want to see so badly, because this asteroid has them. We know it. We just got to find them.
Right. Definitely. But nothing rocky, but nothing too smooth either. We're really looking for that Goldilocks spot right on
small
Bennu.
stuff. And this object may be a loosely bound rubble pile of bits of stuff all linked together, kind of in a foam core kind of stuff. And if it is, that'd be great, and we'll be able to tell when we get there as we orbit this object and measure what it's like. And so we haven't really studied those kind of objects yet. So it's all new. It's all good.
All right. Well, thank you, Jim,
Thanks.
and congratulations once again, and congratulations to the
Go
OSIRIS-REx
Rex.
team.
Great job. Thank you very much, Sarah. Thank you, Jim. Lots of excitement continues. We are about 5 minutes away. From the OSIRIS-REx spacecraft attached to the Centaur rocket, making their way across the African continent. From Cape Canaveral, Florida to Africa in 30 minutes, 45 seconds. We're about 2 minutes away from the restart of the Centaur's second stage engine, scheduled for 33 minutes and 48 seconds after launch. You're looking at real-time telemetry-driven animation showing thrusters firing on the Centaur spacecraft to steer the rocket in the proper direction.
In preparation for the MES-2 start sequence, Centaur has gone to full 100% settling on the 4S motors. Signatures look good.
Marty Malinowski describing the upcoming MES-2 burn, standing for Centaur main engine start 2. This will be about a 6-minute, 50-second burn, commencing a little under a minute from now.
And Centaur has begun the solar vector roll bias. This second burn of Centaur is scheduled for 407 seconds in duration. We are still settling at 100% 4S motors, still forming the solar vector roll at this point in time. And Centaur has completed its solar vector roll, still settling at 100%. on the 4S motors. Under 2 minutes to mess. And Centaur tank pressurization is underway for the second burn. One minute to mess. Centaur has gone to dual branch fuel pressurization. Fuel pre-start is underway. LOX pre-start has begun. We have the first bypass cycle and ignition and full thrust. Chamber pressure looks good.
And the Centaur second stage engine burn, MES 2, is underway.
Good response to the start transient. Centaur EU is running the oxidizer stop at this point. Chamber pressures look good. LOX pump discharge, fuel venturi, all within expected band. RCS line temperatures continue to remain at bottle temperatures. Foliage pressures in both tanks look good. Storage bottles do as well. RL10 continues to perform well. Chamber pressures look good. Controlling near nominal MR at this point. Vehicle bite rates are controlling down the middle as well. Tank pressures are stable.
The Centaur burn, still scheduled to be 6-minute 50-second burn with an expected cutoff about 44 minutes after launch, about 5 minutes from now.
RL10 continues to perform well, still controlling near nominal MR. All signatures look good at this point. Current altitude, 104 miles. Downrange distance, 9,657 miles. Current velocity, 19,854 miles per hour.
Tracking data showing the location of the OSIRIS-REx spacecraft.
Centaur systems continue to perform well. continuing to see our thermal conditioning firings on the reaction control system. Fine temperatures again, have warmed towards bottle temperatures. All of that is stable. RL10 continues to perform very well. All Centaur systems continue to look good as we accelerate at 1.2 Gs.
Just about 2 minutes away from the expected Centaur main engine cutoff number 2, and based on the ignition time.
MR, RL10 chamber pressures, box pump discharge, fuel venturi, all look good.
Everything continues to be normal. Managers predicted that some of the real-time start and stop engine ignitions and other events could change based on the performance, and everything continues to be normal. But based on the current Centaur main engine start, we're predicting a cutoff at about 44 minutes after launch.
Approximately 1 minute remaining in this burn. All Centaur systems continue to look very good. So we're at 1.6 Gs. RL10 chamber pressures, LOX pump discharge, venturi all good for the nominal MR. Centaur continues to look very good. RL10 performance is good. RCS continues to show typical thermal control firings. Line temperatures are good. Tank pressures are stable. Expecting MECO momentarily. And we have MECO. Engine shutdown looks good. We have 4S settling on. We have begun the turn to the PTC attitude.
Main engine cutoff number 2 occurred about 44 minutes after launch. Another coast phase is underway. This one expected to be about 15 minutes, targeting the new spacecraft separation time at approximately 8:04 p.m. Eastern Time.
This coast period is scheduled for 15 minutes to ensure we have visibility to Canberra for the spacecraft separation. Centaur has begun the 50% 4S settling. Signatures look good.
As we're watching the Centaur rocket maneuver to the proper position for the deploy of OSIRIS-REx. We have a video about the target of OSIRIS-REx, the asteroid Bennu, that we'd like to show you right now.
The Milky Way, home to billions of stars, rising and setting over billions of worlds, including our own. In this vast expanse, how did our sun, the Earth, and the planets come to be? In recent decades, our understanding of the solar system's evolution has greatly improved, but deep questions remain. To answer those questions, astronomers are preparing to visit someplace very small. Asteroid Bennu. A lump of rock and organic material, the early building blocks of the solar system, of Earth, of us. Bennu is a time capsule, and its journey takes us way, way back, 4.5 billion years. The raw ingredients of Bennu and our solar system originated in a stellar nursery, a vast cloud of hydrogen, helium, and dust. Our own sun doesn't yet exist. Nearby are hot stars like this one, quickly burning up its fuel and destroying itself in a colossal explosion called a supernova. The explosion destabilizes our cloud, causing it to collapse. In the geologic blink of an eye, 100,000 years, gravity and angular momentum flatten the cloud into a swirling disk. In the center, where molecules crash together tightest, a protostar revs up to incredible pressures and temperatures. Deep within the disk, clumps of dust not much larger than a grain of wheat are flash heated into droplets of molten rock, called chondrules. The source of this heat remains a mystery. Chondrules are destined to become the building blocks of the solar system. Coaxed by gravity and turbulence, the chondrules clump. They grow into the first asteroids, into mountains, into planets. The asteroids are rubble piles of rock, metal, ice, and organics. This large asteroid is the parent body of Bennu, a protoplanet whose size we can only guess. Closer to the protostar, a planet begins to form. And then, dawn in the solar system. The protostar undergoes fusion and ignites, revealing our sun. But the solar system is far from finished. Jupiter most likely forms near its outer edge, but just 500 million years after the sun ignites, some believe that it slowly moves inward. Its massive gravity ripples the asteroid belt, disrupting countless asteroids and comets, flinging them toward the sun. They rain down on the inner planets, hammering and remelting large portions of their crust. Did these impacts also deliver organics and water, key ingredients for life? Back in the asteroid belt, Bennu's parent body is lucky. It survives this period of heavy bombardment. The solar system cools and calms. Jupiter and its many moons assume the orbits that we see today. Billions of years of quiet follow, more or less. Then 1 billion years ago, one theory suggests a collision shatters the protoplanet. Some of the debris loosely coalesces into a new, smaller body, Bennu. But Bennu will not stay in place. Dull, non-reflective, it slowly migrates toward the sun. Solar heating turns its warm side into a low-intensity thruster. Through millions of years, Bennu's orbit gradually tightens until it interacts with Saturn's gravity, altering its trajectory and hurling it into the inner solar system. close encounters with Earth and Venus follow. Their gravitational tugs may have repeatedly stretched and reformed Bennu, turning it inside out and pulling off loose material. As a result, it has no satellites of its own, until now. Today, NASA is sending a spacecraft called OSIRIS-REx to explore Bennu and retrieve a sample. Why? Bennu has survived its long journey and settled into a near-Earth orbit, bringing its secrets within our reach. Now it is ready to teach us more about the solar system's history, its formation, its evolution, and our own place among the stars.
And we're back looking at telemetry-driven animation showing the OSIRIS-REx spacecraft atop a Centaur rocket, making the way to deploy attitude, altitude, and location. Spacecraft separation, we believe, is now targeted for 8:04 p.m. Eastern Time. Once the spacecraft has been deployed, 2 solar arrays are scheduled to be extended. And then as the spacecraft passes over Deep Space Network sites run by NASA, we'll acquire the spacecraft and gauge its health. So far, everything has gone perfectly to plan.
The OSIRIS satellite that they sent out. Yeah. So I put it on NASA Live TV and I'm sitting here watching it and recording it. I thought so. Yeah, we're waiting for the satellite to come back up before it makes its way out to a asteroid that will be
a video to teach us even more about what will happen with the sample once it is retrieved and returned to Earth.
My name is Jason Dworkin. I'm the director of the Astrobiology and Control Laboratory at NASA Goddard. I'm
It's
also the
take
project
about 7
scientist for
years
OSIRIS-REx.
to do the whole thing, but they're sending
We're
it over
interested
to
in
go
studying the
grab a
origin and
sample
evolution
from
of life
the
on the
OSIRIS
Earth and other
grab a
bodies in
sample
the solar
from
system
the
from the perspective
asteroid,
of
and then
understanding
bring it back
simple
to
organic
Earth.
chemistry. We don't understand what happened in the ancient Earth. Most of that record is lost by subduction and other geochemical processes. However, meteorites and the asteroid Bennu witnessed the chemistry of the early solar system. A problem with studying meteorites is that they invariably land on the ground. They land in ice in Antarctica, for example, or in dirt or soil, and life very rapidly contaminates these samples. By going to collect the samples from an asteroid, we can keep the samples pristine by having very tight controls over what the spacecraft is made out of and how it's returned and archived and distributed around the world. OSIRIS-REx is a NASA mission which launches in 2016 and goes to the near-Earth asteroid Bennu, which is a organic-rich, very dark, primitive asteroid. Orbits the asteroid for about a year, studies it in great detail, and then collects a sample and returns it to the Earth for worldwide distribution and study. Samples from Bennu return to Earth in 2023. They land at the UTTR facility in Utah, then are transported to the Johnson Space Center in Houston. Any scientist in the world can write a proposal to request some sample and justify what they'll get from it. The Bennu samples will contain riches which can be studied today and are in many ways beyond technology right now to study. For example, in this laboratory, we've been studying samples brought back by the Apollo missions. The analysis is being performed by a woman who was not born yet when the samples were returned, using instrumentation that was not designed, asking questions not thought possible. This is the value of sample return. It's a gift to the Earth that keeps giving generation after generation as technology is advanced and as new people come up with new questions that we're not smart enough now to think about.
After a successful liftoff from Space Launch Complex 41 in Florida, we're less than a minute away from the deploy of the OSIRIS-REx spacecraft into space. Center has begun the transverse spin-up. Standing by for spacecraft separation. And we have indication of spacecraft separation. And as the spacecraft soared high above the western tip of Australia, OSIRIS-REx has reached Earth escape velocity of more than 22,000 miles per hour and is flying free on its way to a 7-year mission to rendezvous with the asteroid Bennu and return a sample to Earth. Celebrations here in the Atlas Spaceflight Operations Center, Mission Director Center, managers from NASA, United Launch Alliance, Goddard Space Flight Center, the University of Arizona, all the constituents concerned with the launch and the spacecraft. A great day for everyone. But we will still stand by for a successful solar array deploy and confirmation of power to the spacecraft.
actual measured position compared to the pre-flight nominal show that spacecraft separation occurred as we expected. Looks like a very good orbit.
This is Atlas Launch Control. A little more than an hour after an extremely successful launch today, we are very happy to be joined by Tim Dunn, NASA Launch Manager for the mission with the Launch Services Program here at NASA's Kennedy Space Center in Florida. Great job. Beautiful,
Thank you so much,
beautiful
Mike.
launch.
Thank you, thank you. Terrific day. Can't say enough about the team. What a terrific performance by the combined Atlas V team. Beautiful day. Everything started about noon here on the east coast of Florida. We powered up the rocket after a great rollout yesterday, and everything went absolutely smooth. All that bad weather we had last week and over the weekend had cleared out. Gorgeous weather here, perfect weather to launch an Atlas V or any rocket, and this was an excellent launch. Great performance by the team. We came in, I guess about 4.5 hours prior to launch. We got ourselves all set up, ready to load the cryo propellants, the super cold propellants on the first and second stage of the Atlas V, and that all went absolutely smooth. Not a single anomaly was worked during the countdown, almost unheard of. So
Yeah, the loops were so quiet, it was unbelievable.
it's a launch director's dream. The team is marvelous. We've got just an incredible team. The combined team here from United Launch Alliance, who does all the heavy lifting in preparing the Atlas V. We've got a terrific Air Force range team that sets up a beautiful range for us to launch on. The spacecraft was absolutely rock solid in its readiness sequence today, and that's all because of the hard work by NASA Goddard individuals in addition to Lockheed Martin. So, and then for NASA here at Kennedy Space Center, our team performed up to the task as usual. We never expect anything less. They're an absolutely great team. They never cease to amaze me, and we were all coming together, the great combined partnership that we have, and we came right down to the T-4 terminal count readiness poll, executed that nominally, came off the pad beautifully with the single solid. It was a great time of day to launch here on the East Coast. The sun was just about a half hour or so from setting in the west, so absolutely gorgeous launch, and we're really ready to celebrate now with a great spacecraft separation.
Well, we'll let you go do that. Thank you so much, Tim. It was an awesome day, and it really was a clean launch and a beautiful site. And congratulations once again.
Oh, thank you so much, Mike.
All right. So we will be standing by for confirmation of solar array deploy, which should be followed about 10 minutes later by confirmation that the spacecraft is healthy. These times are approximate, and we'll keep you posted as we learn information. For now, with a successful launch, we would like to replay launch videos. This is Atlas Launch Control. At 13 minutes past the hour, we have positive confirmation that both solar arrays have deployed on the OSIRIS-REx spacecraft.
Hi there, everybody. If I can give your attention. Incredible job you did. This was superb to watch. We had the Secretary of the Air Force down here, and I was telling everybody it was her first launch ever. And she went away mesmerized by watching you all work. So on behalf of all of us around the country, to be quite honest, but particularly me personally, I just want to thank everybody, the whole team, for what you have done and what you've started. We've got some long time ahead of us, but I plan to be in a rocking chair 7 years from now and watch the capsule as it comes back and lands up in Utah. So again, I cannot thank you enough, but go home, hug your kids, hug your wife or husband, or your girlfriend, boyfriend, whatever it happens to be, and tell them that the NASA administrator said thanks so much for allowing you all to come and do what you love, and just thanks again. Take care.
Once again, applause here in the Mission Director Center as NASA Administrator Charlie Bolden addresses the launch team and the mission teams with a hefty congratulatory message.